I think, yes, this is the future, but we should wait for it.
Fast, charged, electromobile. Welcome to EV generation, a place where the future becomes reality.
Welcome to another episode of EV Generation, a podcast where we guide you through such topics as ecology and technology to lifestyle and new mobility trends. My name is Marina. I'm passionate about e-mobility, sustainable transportation and ecology. And my guest today is Tomasz Lipinski from Photomate. Hello, it's very nice to host you here.
Hello, thank you for the invitation and thank you for having me here.
For the beginning, could you say a few words about your company, your role in the company, what you are doing?
Yes, I work as EVSC division manager, so I'm responsible for EV charging, so that's why we are here. But the origin of the company is we are the global distributor of PV inverters, so we deal with photovoltaics, but also energy storage system, transformer station, and all the other stuff that is connected to this. So we are also expanding our portfolio. We are dealing right now also with the EV chargers, but also with energy management system and other elements of the ecosystem related to renewable energy sources.
That's why I have a lot of questions about integration in mobility and renewable energy sources. It's obvious that the main sustainability goal is to achieve less reduction of CO2. And we could achieve this goal if our electric vehicles will be charged by energy produced by renewable energy. And how integration between e-mobility and renewable energy look like in different countries in Europe? I guess Scandinavian countries are leading the way, but how does it look like in other countries and in Poland?
Yes, but first we have to talk about what is renewable energy source, because when people are thinking about this kind of source of energy, most people will say, okay, wind and okay, PV plants. But when we are talking about Scandinavia, for example, in Norway, but also in other countries, then most of the electricity comes from hydroelectric power plants. So it is not only the wind, not only the photovoltaic systems, but also hydroelectric, also some waste or biofuel and other elements that are better than fossil fuels. So of course, Scandinavia is leading that way, because almost all, in some countries, almost all of the energy comes from renewable sources. But when it comes to other countries like Poland, it's not looking so good. Of course, there is a rapid growth of PV plants and also some new wind farms and all other ideas how to reduce the CO2 in Poland, how to get out of this coal-related energy sources. But it's the process. We are speeding up, but it depends from country to country, because this mix can vary from one place to other. Of course, we would like all to have the clean and green energy as in Scandinavia, but it takes time. It doesn't go just by one click. So it's the whole process. But for sure we can say that it is the green energy, it's developing, and there are more and more challenges ahead of grid operators.
Renewable energy are more sensitive for change of the weather. Could e-mobility help to stabilize renewable energy grid?
Yes, of course. Here is once again the some kind of division of the sources, because hydroelectric power plants are more or less predictable. Of course, there's some climate change and the different levels of water in some places. But when it comes to PV plants, yes, of course, it depends on the irradiation. So it depends on the solar energy that is coming to panels. The wind, of course, wind turbines depend on wind, and these are conditions that people cannot control. So yeah, those are the sources that are more or less hard to predict because sometimes you can predict something, sometimes not. But of course, e-mobility can be some kind of remedy for those problems, because for now in residential sector we have many different components of the system that enables us, for example, to charge the car when we have some excess energy from PV plant, or during some, for example, low price tariff. So this is the micro scale, so everyone in his home can balance the grid from his point of view. So it's just like the micro scale, but when it comes to bigger scale, for sure in the future some technologies will be more and more popular that will also enable the e-mobility and the batteries in the cars to be used also for other services to stabilize the grid. So for sure it's the e-mobility, it can influence the grids, can influence the energy sources, can stabilize the grid, but in the future I think the technology will be developed more, and there will be more and more electric cars, so the scale of the regulation will also be bigger.
And which technology could support this integration between e-mobility and renewable energy sources?
Yeah, the first, I think there are two main elements. First is something related to what I've already said. So the energy management system, the electric vehicles and the charging of electric vehicles is quite, from the electrical point of view, it's the load that can be almost fully controlled, because you can control the power of the charging, of course, not starting from zero, for example, for AC charging, but anyway, you can control the load, so you can adjust the load by some energy management system and just use the, for example, excessive energy that would come to the grid to charge your car. So you just connect your car, and energy management system is developing how much energy goes to electric vehicle, just for example to utilize the power coming from the PV plant, or for example do some other requested behavior of the charger. So EMS is the first thing. The second thing is, of course, the battery energy management storage system. So like the storage system that will like accumulate the energy coming from renewable sources. It will not destabilize the grid. It will be stored, and you can use it, for example, in the evening when you have no PV power, but you have stored it in your ESS, and just withdraw it and use the green energy for charging your car then. So I think those are the two technologies that are already being implemented in small residential solutions, but also coming more and more popular into, let's call it, industrial scale of charging and stabilizing the grid.
So when we are talking about energy storage, so for example, when we are building a hub for electric vehicle, we build also such energy storage. It's integrated between, and for example, we could have a bigger power of charging a car than a hub actually has.
Yes, this is another good example, because we can integrate the energy storage system with, for example, PV plants, but it's not necessary. We can just use energy storage system to boost the output power of the charger, because there are many problems in the grids that there is not enough power, and someone, for example, would like to have, I don't know, 400 kilowatts charger, but has only 200 kilowatts of the power on the point of connection. And he can use, in some cases, energy storage system to boost it, because, of course, when it comes to EV charging, and you can see that for DC charging, every EV has some different charging curve. And when you have low power charger, the peak of the charger ability or capacity of the car is just shaved, and the charging takes much longer. Yeah, but when you, for example, use energy storage system, you can cover the peak with the you can install the charger of the higher power, of the higher capacity of charging, and you can use the energy storage system as a booster. So then when you have some energy stored in that ESS, you can use it, you can discharge it during charging, and then, for example, refill the ESS when there is no car connected. So that gives you opportunity to charge in the very fast way, even and use higher power chargers when you have not enough power coming from the grid.
I guess it's really very interesting implementation. Do you know about such implementation in Poland, for example, or in Europe?
It is like this technology of energy storage system is still under heavy development, and we have every technology comes with some demands from the technical point of view, and also from the standardization, and also from the law that is in every country. But as Photomate, we are still improving the solution that we offer in that term. We have two already working training centers and test facilities. One is in Jabłonna near Warsaw. We are there cooperating with the KEZO Institute. It's the Polish Academy of Science. And we have there some good opportunity to test those solutions, because we have, or the KEZO has there quite big PV installations, also some wind turbines, and energy storage system, and the DC charger. And we are combining all those sources together and enable the employees of KEZO, but also the guests, to charge their car at the higher power that it will be possible when the charger will only use the connection from the grid. So another such facility we have in Czech Republic. We have our headquarters in Czech Republic, in Hurka, near the border with Austria and Germany, and there is also another working project. And at this stage, we are developing in Poland, because there will be new subsidies, for example, for the heavy-duty vehicles, of the trucks, and there will be some subsidy for that will also cover the energy storage system. So we have some projects in the pipeline. We are already started to help our customers to just be ready for this subsidy, because it takes time when you want to connect energy storage system to the grid. You need to get proof from your operator and so and so. But we are helping our customers, and it's already underway. So we have the working solution, and we know we can implement it in. And the good thing is that this solution is also scalable. So you can use it from the boosting some small charger, I don't know, 60 kilowatts, and you can use it for boosting the big hub. So it is like another puzzle in the system that can be controlled. And from this point of view, for sure, the users of the EV should benefit from it in very fast charging in the future.
Yeah, definitely. And what about vehicle-to-grid technology? How this technology helps to integrate e-mobility and renewable energy sources? And do we have any examples of implementation?
It is like the V2G technology, for sure, is at the process of heavy testing, I will call it, because the problem is as I mentioned, there is some technical obstacles that are on the way, then some standardization, and then the law in every country. But for sure, the number of the EVs are still growing, and in the future, they might be a good opportunity to use it for different purposes. Also, giving power back to grid when it's needed. I think there in some future that will be possible. And now, of course, there are some already implemented solutions, mainly basing on some DC wall boxes with cars that are ready for it. So Nissan Leaf and Shademo connector, there are some elements that can be used now. But we should also consider that it should be legal, because when you give your energy to the grid, for example, for PV inverters or for power conversion units for ESSs, there is some certification needed and some process of how the elements should behave. So it's, I think, this is the future, but for now it's like still under development. And of course, when we are talking about, for example, vehicle to load, vehicle to house or something like this, it is now spread almost every manufacturer of the car is enabling it. For now, the new models of the EVs for sure are ready for the V2G. Maybe not all of them, but there are some manufacturers that are ready for it. But I think we must wait for a while to that the producers of wall boxes, or in the terms of charging at home. So there must be like a wall box or some other element that is able to deliver the energy to the grid. There are already some products there, but also there must be car ready, and the like grid operator should be also ready, because you cannot just give the energy to the grid. It's you would have to be like, this energy should be measured, and you should get some, for example, payment for it from the DSO for your services. So I think yes, this is the future, but we should wait for it. We should wait for it, because there's also some other elements, like you use your battery in the car not for movement but for like charging, discharging. There are some issues with the faster degradation of the battery, and also there is some efficiency. So yeah, the electromobility is still like developing, but please remember that it is e-mobility. So the priority is to use your car for moving, and for example, when you leave your car on the charger and the operator says, okay, now I need your energy, and you are
and you need this energy in that moment.
Yeah, and you want to go somewhere, there can be a problem, or you just stay with your battery out of SOC, out of power. So I
imagine that I will have this application. For example, I have noticement that I want to get your power. Do you agree of that or not? So I guess that it have to be some software solution for that.
For sure there will be some software solution. Of course, I'm kidding, because for example, there will be for sure your battery car will be divided into some portion that you need for mobility. So for example, you would like to go to the cinema by your car because you're living not in the city, you cannot go by metro or something like this, but you want to use your car, and you have some reserve capacity for this, and the rest is for the operator, so or the EMS system that controls it. But for some services it may work fine, but for some the operator needs to be sure that you will be able to deliver that power. So if you decided, should I use this power or not, that the operator won't be interested more or less on your services if you are not willing in 100% to reserve the power for their operational ability. So.
And what about smart grid? What is that, and why it is important? And it's also in some phase of testing, or it's already function somewhere?
Yeah, so the smart grid is like the quite, I would say, big term, because the smart grid is basing on communication between different elements. So the generators of the energy, so the sources, but also the recipients controlling all the loads, but also smart metering. The metering of the energy flow. It can be also integrated with some sensors, some intelligent sensors that can, for example, self-diagnose some part of the installation. So smart grid is quite a big term describing the whole communication between different elements in the energy grid, but more or less, the stability of the grid is when the generated energy is equal to consumed energy. Yeah, so this is like the process of controlling the generators and most of all also the loads to have the grid under control. So this is the why, for example, in smart grids, there are some commands set, for example, to some loads to just lower the load, or to just accumulate some energy, or to, for example, start additional generation. So the smart grid is quite big topic to discuss, but for smart grid, the system should be reliable, should be communicating with every element to be stable, to be not prone to, for example, cyber attacks, to be that this is also some important nowadays, that all the elements should be safe. I would say it's the safety of the energy flow, but also there are like more and more used, for example, AI boost, so the predictive algorithm, some prediction of generation of the renewable sources. There are some different elements in the grid, and this smart grid means that every element is communicating with other elements to make the system as much stable as possible, and also of course cost efficient, because everyone wants to use the cheapest possible energy, coming from the green sources and all these elements. And nowadays, of course, the different elements of smart grids are more and more popular.
So to sum it up, if we are talking about integration of e-mobility and renewable energy sources, there are two main technology: energy management and energy storage. And also
most important,
two most important. And such technology like smart grids or vehicle to grid are developing now. And maybe there are another technology you want to talk about that are very important in this integration too?
I think there's there's some different solution depending on the scale of the project, because everyone can have some smart solutions even in your house. So for example, you have the EMS in your house that is depending on the scenario, because it depends what you want to achieve. But for example, let's say that you want to accumulate the energy or use the maximum self-consumption. So you want to not to export the energy to the grid, and because in most cases now, when you are exporting the energy, it is not so profitable. It is better to use it here and now, or to store it for the future. And for example, it can be the electric vehicle. You have some EMS to control the charging process depending on the meter on your point of connection. So for example, it is controlling the charging process. It is like allowing the car charging faster or slower, just to not export the energy. But it's the e-mobility. You can also do it with, for example, some heat pump or some other elements in your home. But of course, going into the larger scale, it is like sometimes more complicated. But because on your home, something can be predictable. You use the same appliances all the time, but in industrial environment there are many things that change. And also regarding the e-mobility, when for example you are building a big hub and you are like thinking about the solution that will be good, for example for boosting DC charging, and you have some PV plants there, of course this solution should be also smart and should be like adjusted to your needs, because if you have hub but no cars to charge, then your PV will just make your ESS full in very fast way. And it's then you are exporting energy because you have no load. So the smart thing is that control in the real time everything, but it's also very good or very important thing to make it like adjusted, all the components and all the scenarios to your needs, because you can invest and you will get no profit from this, because for example nobody will your system will be smart, but if nobody is charging your cars there, it is like
no benefits of it.
It doesn't have the chance to be smart. So it's like more or less some elements that are automated, but they should be chosen the right way.
I have one question, last, our traditional. If you could change one thing in e-mobility world, what could it be?
I think if I can choose only one, there are some minor. I think that e-mobility is growing, and I'm also using EV, and the one thing that I could change is probably the mindset of the people who are talking about it, but not trying it.
Yeah, totally agree. Thank you very much for this talk.
Thank you.
And thank you that you were with us and listening to our talk. Let me know in the comment what it was the most inspiring thing for you, and what do you think about integration in mobility and renewable energy source. And join us on the next episode of EV Generation next Thursday.
Fast, charged, electromobile, EV generation. A place where the future becomes reality.